In this last video, we're going to try to take all of the ideas that we've talked about in Chapter 8 and kind of roll them up into one big problem. So I have in this table the life expectancy for certain individuals born in the United States based on the year that they were born. So I have all of this data. First question that I have is decide which should be my explanatory variable and which should be my response variable. Remember, our explanatory variable, that's really just our x variable, and our response variable, that is our y variable. Now, when we talk about which one we should use for our x and our y, in general, we want to think about, would it make more sense to use the birth year to make a prediction about life expectancy, or the other way around? Would it make more sense to take life expectancy and make a prediction about the birth year? I tend to usually take the time, in this case the year, almost always as my x value. Generally, if you have a time or a date or something like that, this is always going to be your x value. And it seems like that's kind of the more easily obtained data. It's easier to get somebody's birth year than perhaps their life expectancy. So the explanatory variable I'm going to use as my birth year. And then the response variable would be the life expectancy. So we're using the birth year as our x variable, our response variable, life expectancy as our y. I'm going to go ahead and label these as x and y in my table, just in case I need them. Very good. Moving on to part B, we want to create a scatter plot of the ordered pairs. This is something you could do by hand, but I do think overall it's pretty tedious. I would encourage you to use your graphing calculator. If you need to, go back and look at the video on how to do that. I'm going to quickly show how to do that, so let me hop over to my graphing calculator. Now, I have the data already entered in, so I don't need to bother with that step. To create that scatter plot, remember we're going to press second, y equals, we're going to choose that very first option, scatter plot 1. Make sure that we turn the plot on, so if it's set to off, make sure we turn that on. Type, we should be choosing that the graph that looks like a scatter plot. Our x list should be set to L1 and our y list should be set to L2. And then we want to make sure that our viewing window is set appropriately. So to do that, if I press zoom and then I go down to number 9, zoom stat, the graphing calculator will automatically set the viewing window for something that makes sense. It's going to show me all the data that I've entered in. So I go ahead and graph it and I say, hey, there's my scatter plot. That's pretty nifty. So you can make different observations about that. You can say, okay, well, we have an increasing trend. This looks like a pretty strong association, a pretty strong pattern that we're noticing here. And perhaps most importantly, we have a linear shape. Remember, none of what we do in this section really makes any sense unless we have that linear shape. Doesn't matter whether it's increasing or decreasing. We want to have that linear shape. So yes, we have that linear shape, and that's actually going to answer my next question. If I hop back to my notes, so part B, we've created the scatter plot. Done. Part C, is linear regression appropriate? Explain why or why not. We just said yes, it is appropriate. The scatter plot has a linear shape. Has a linear shape. So anytime the question asks, is it appropriate to use linear regression, or is it appropriate to talk about the correlation coefficient? It all comes back to the scatter plot. Does it have a linear shape, or does it have a non-linear shape? Or perhaps does it have no association at all, in which case it would not be appropriate. But you're looking for that linear shape. In any other situation, it's not going to be appropriate. So next step, I want to calculate my least squares regression line. So I have to hop back to my graphing calculator. So over here, again, I've already entered in my data. I've already turned on the diagnostic. So there's nothing else I need to do. I'm going to go back to my home screen, pressing second mode. And then if I press stat, We're going to arrow to the right so that we're under calc, and then we're going to scroll down to number 4. It says linreg ax plus b. That's the one we want. X list should be set to L1. Y list should be set to L2. We shouldn't need to do anything else. And then we go down to calculate, and there is our least squares regression line where it's ax plus b, and they gave me the value for a, and they gave me the value for b. We're just going to go ahead and plug those in. So a is equal to 0.227, b is equal to negative 377.243. So let me hop back over here so that I can write down my least squares regression line. My least squares regression line is y hat equals a 0.227, that's my slope, times my x value, plus b. In this case, b is negative. I'm just going to make that a minus 377.243. That's my y-intercept, and we may be talking about that later on in this problem. But there's my least squares regression line. I don't need to do anything else. Part E, moving on, says find the correlation coefficient. When we talk about the correlation coefficient, that should be our R value. We're looking for R here. So if I scroll back, go back to my graphing calculator, we are interested in that R value, 0.961. So 0.961, that's going to be our R. Remember, if that R value is not showing up, you need to turn the diagnostic on your calculator. So you can go back and watch the video on calculating the correlation coefficient using your calculator. I'm not going to talk about that again here. So we have our correlation coefficient. R is equal to 0.961. And that tells me that I have a really strong positive relationship. Remember, R is between 0 and 1. It's between negative 1 and positive 1. I'm thinking ahead here. R is between negative 1 and positive 1. The closer it is to negative 1 or positive 1, the stronger that relationship is. And if it's positive, that means that you have a positive slope, a positive trend. If it's negative, that means you have a negative slope or a negative trend. So we've got a pretty strong positive trend here, as we saw in the scatter plot. Moving on to part F. Part F says find the coefficient of determination and interpret it. So the coefficient of determination is R squared. We want to talk about R squared. So again, I'm going to go back to my graphing calculator and oops, shoot, I lost it. All right, let's go back. Stat, calc, we're going to go down to linreg ax plus b, press enter. Let's go down to calculate. Everything should be good. We're looking for R squared. So R squared in this case is 0.924. So that is our R squared value. So R squared is 0.924. And this actually represents a percentage. This is 92.4%. And if I wanted to talk about what that R squared value means, it means the amount of variation in our Y value that our model can predict. So our regression line or our model can predict 92.4% of the variation in our Y value. And we said our Y value was life expectancy. So our model is pretty dang good. Expectancy, I think it's an A. Our model is pretty dang good at calculating the life expectancy. It can account for 92% of the variation, which you're not usually going to get a whole heck of a lot better than that.